So I'm getting away as far as I can tell. So I haven't got anything.
Let's get started. Today we are delighted to have Sanjay here from NT. As you know, NT has made major changes in their development process, and he's going to tell us how they have advanced it, and also talk about the challenges that lie ahead, which are the areas where we can help him in the future.
Thank you. So one thing which we are talking about now, we're looking for, when Amitabh told me to come here and talk about a topic, one of the things which we thought was going to be useful is just spend some time explaining some of the problems and challenges which we are facing while we shipped Windows 2000 and are working on next release of Windows in the engineering teams. Some of the challenges which we are going to talk about here are specific to engineering process and development process and QA related issues, and because that's what our knowledge base and experience is from. One of the things which I did for Windows 2000 was managing all the test and QA effort for Windows 2000. So most of the data is based on that. So I'll start with oops. Yeah, I had to just pick a short list of things to talk about, and I want to make it as informal as possible. So if you have any questions, you can just ask as we go along, and later on also we'll have a QA session. Some of the things which I kind of categorized these challenges into is one thing which we did recently is roll out the Source Depot environment to actually have a distributed build environment for NT. I'll talk. This has been an overall success to allow us to actually do more things in parallel, but it does come with some of the challenges associated with rolling out such kind of a solution at this scale of NT source code. So I'll talk about some of that. The other topic is this dependency analysis. This is like a class of problems which we can actually solve in this area. There are lots of ways in which a lot of teams can benefit if we can do some work in the area of dependency analysis. I can give you some of the specific questions which we have during the release process for which the tools developed in this area can help us. The other area is robustness and reliability. A lot of work has already been done. When we shipped Windows 2000, we actually experimented and tried quite a few things to have metrics to measure our server reliability. There are few things which we learned from it and want to spend more time understanding some other aspects of measuring reliability and robustness. We'll talk about that. And this whole area of exposing defects without code execution is very attractive. One great example is prefix, and we have been aggressively using prefix in our teams. But there are quite a few other things we could do in that area to really speed up the process of finding problems earlier on in the development process, because by the time you actually find it through testing, it's pretty late in most of the cases. And another major area is the exploding test matrix, where as we add more and more features to the system, this matrix of test matrices just keeps exploding, and anything which you can do intelligent to actually contain that is going to have a lot of productivity gains for us. And at the end, we'll try to summarize what are the my wish list of 2-3 areas where we can focus more if we have an opportunity. The first topic is the challenges in the distributed build environment. I don't know, most of you folks must be aware of Source Depot. If you are not, I can spend a minute to talk about that, but I'm assuming that you know Source Depot environment. So one thing which it has done is we have actually created about 8 to 10 virtual build labs for NT, and we have partitioned the whole NT source code base into depots, about 8 to 10 depots, and all these virtual build labs have started doing all these things about integrating from the main tree and reverse integrating back into the main tree on a periodic basis. And this is a short list of some of the challenges which we are facing in rolling out some of the Source Depot environment. One major hit for us, of course, is the test bed explosion, because each of these VBLs, initially we used to have one central main lab where we used to do build verification before the build is ready for the customers, inside customers, if you will. Now, if you really want to do a good job of making sure we are not breaking each other, then in addition to allowing the developers to pump in code in all these virtual build labs, we also have to make sure that they make investments to make sure the BVT test beds and the processes are also replicated along with the ability to build. Otherwise, the quality of the code they check in into the main tree, if it's not good, then you're not making fast progress. All you're doing is adding more code. So test bed explosion and distributing the test beds is one of the things which we are going through right now. It's pretty expensive to do that if you really want to do a good job of that. Another complexity is, earlier it is very clear if someone finds an issue, which tree it is in. Now we have created so many trees and so many forks and VBLs that really tracking the bugs across all these VBLs and tracking the resolution of all these things. We had to do quite a few things in RAID and munch some of our RAID fields to track some of these things so that we can have that level of information. When someone says he has resolved the issue, where exactly has he resolved? Is it on his machine or a VBL or a main tree? So you have to deal with that complexity there. Triaging across VBLs is another area which is still kind of unsolved right now, because initially we were pretty good about, if there is a break in the system, it was very clear. You just send out mail to the owners and they would actually take care of that problem. Now, if the problem is isolated to that component in which the VBL has made the change, that's easy. But if we actually encounter a problem in some code base taken from the other VBL, that creates a lot of problem, because no one trusts, whether they are responsible to break that or something else has happened in this VBL. So this escalation paths to track issues across VBLs is another process we have to kind of come up with. Some solutions to quite a few of these things are not really tools or technical challenges. They're mainly processes and how do we deal with those things. So that's what we're going through right now. Another challenge is, if you look at some of these words, they kind of, anytime you distribute the problem, there are some typical distributed system problems. So similar to that, even the fixes which we make, the latency with which they kind of replicate across VBLs and into the main tree, they replicate at different time lines. So at any stage in our process, there is some wasted engineering bandwidth, I think, when the problem is already fixed somewhere in some VBL, but by the time it actually goes to the main or the other VBL, a bunch of other people are kind of suffering from that problem and not knowing what's happening. Another challenge is to actually keep the coherency of all these tools and environments which we use. If you're not very careful, very soon we find problems where the compilers, the flags, the linkers, the exact environment which we use in VBLs needs to be identical. Otherwise, we will be causing a lot of confusion when we integrate into main tree. So that's also a challenge, to keep updates of all these things synchronized across all the VBLs. The other problem is the circular dependency of the VBLs. Quite often we get into the situation where a VBL wants to actually make a change and put it in the main tree, but they're blocked because they need a change from VBL2, and VBL2 is blocked by VBL3, and there needs to be a process to actually coordinate that and unblock that deadlock so that we can start moving forward. So that also, we are having some yeah, go ahead.
Yeah, can you give us a quick idea of some of the time frames involved here? Like, if somebody forks off a copy from the main tree, how long do they tend to hold it? A week, a month, several months, a year?
We actually have a overall policy. Sometimes we are able to enforce it, sometimes it's difficult, but we encourage all the VBLs to integrate from the main tree very frequently. Every week they have to do that, so that they, in the VBL, they get a good idea of what's happening in the main tree, and they're testing their code with that drop. As far as reverse integrate, that's a process where VBLs go back into the main tree. That also, we have a goal to make sure the VBLs don't go more than a week without reverse integrate. Now, that is the goal. Now, initially, we were not able to achieve that goal. A lot of chaos was there, and people were kind of ramping up. But steady state, I think that's what we will do. And the way we are actually dealing with this stuff while we are developing the system is going to be a little bit different than when we get into the showstopper mode and the final stabilization of the system. At that time, we would gradually, reduce this distributed model and focus more on the main tree, because that's what we're shipping. But initially, it's going to be mainly VBL focused during the initial development process. So that's the guideline.
So at that point, do you drop everything from the VBL back to the main tree weekly, or do you drop selected bits of it?
The well-tested drops from VBLs come into the main tree approximately once every week.
So does a VBL have to stabilize a build weekly before dropping it back?
That's correct.
They can drop parts of their tree.
Now, they actually, how they define the drop is up to them, but it has to meet certain quality bar. So one of the things which we are doing is the build verification tests which we had. We are automating those and packaging them and distributing them, so that all these VBLs have certain what we call core DBTs, which all of them have to pass before they reverse integrate. And the size of the drop depends on each VBL, depending on the timeline. Some of them break it up into lots of small pieces and reverse integrate quite often. And some of them, if the complexity of the code is big, then they just wait for a couple of weeks and then do it. So that comes to the next topic here of less granular information about the change. It's pretty much up to the VBL of what the unit of change is. So we get changes in huge chunks now. So it's very difficult to figure out exactly what has changed from build to build. There's like huge blobs coming in.
You can't carry over the change information from the VBL to the main?
The change information, when we had this main BBT and the main build lab, we were pretty thorough about exactly demanding that level of information about what exactly changed per change. But now, because of this distributed nature, each VBLs, they are not having that much of control over when the change is made into the VBL. They are a little bit more relaxed about how they go about adding things into the VBL.
So Source Depot gives us more capabilities to track. Just a matter of process thing more?
It's just there's some cultural issues involved. In terms of how much overhead you want on a developer to keep bookkeeping each and every small change before it gets into the main tree. But one thing which we are going to do is, as we get closer to the milestone, in main build, when we get into that milestone, we will force that level of information to be kept using Source Depot methods or other tools. But right now, it's a little bit chaotic in the initial phase of the development process. And the other thing which we have to keep emphasizing to people is developer productivity is not just more code in less time. It's very important that you have more code of higher quality in less time. Otherwise, it's very easy to get into a situation where tons of code comes in and then it takes longer to figure out what, untangle the mess. The other problem which we have is fragmented test bed pool in general. Earlier it was very clear. We had this 1,000 machines doing certain thing on a particular day, and then we could actually say, okay, 98% pass for robustness or stress. Right now, all that test bed is kind of fragmented between 10 VBLs, and some of them are in the main tree. We have to be more careful about making sure that the sample or the size of the test bed is statistically significant for us to kind of make sense that, yep, what's happening here? Is it, in some cases, you just have to invest more and make sure more machines are added on the main tree so that we have good data on that. So there are a lot of issues, process issues, there's some investments you have to make sure test beds are replicated, and that's the phase we are going through right now. But so far, overall, I think it's been a very positive change to the team. The next topic is this change notification. In general, what we find is the way we communicate changes, and that comes back to what Patrick was talking about, how do we make sure everyone knows what is changing. The way in which we communicate that within the team is very inefficient right now. even if we force people to kind of say, which module changed, which binary changed, and all that stuff, even that information is not very actionable for a bunch of other teams. To make sure that the change is put into the system in a way in which it's actionable, one of the typical things which a test lead or a manager wants is, okay, you make this change, so what are the key set of test cases I need to rerun because of this change? Or what is the cheapest way to make sure that nothing else is broken when I make this change? Sure.
Actually, on the previous, you divide job by means of these VBLs.
Uh-huh.
What is the principle? What constitutes, what part of
how do you partition it?
how you partition? And when the partition is stable, do you have to repartition?
The,
You do it once for all?
actually, if you do it once, I think throughout the release of that particular release, I think we should just stick with whatever depots we partition it with. And the way we actually partitioned it is to allow maximum parallel development and reduce the dependencies. So if there's some collection of code which is managed or developed by a set of people independently, that's a good block to have it as a depot. But it's impossible to do that. There are dependencies which are kind of indirect between the components, but at least that was our guideline. And then we just picked 8 to 10 VBLs as a good enough size because it kind of maps to our org structures also a little bit. So we could say, these are the technologies and these are the set of, several hundred people here, several hundred people here, and each of these folks get VBLs. So it's a combination of mapping to right org structure and mapping to different components in the system which have less interdependencies with each other. And there is cost of overdoing it also, because more granular you do that, all this cost of replicating the test beds and the processes and the communication overhead and all that stuff also increases. Okay, so those are the typical questions every test manager wants to get answered about. How do I make sense of this change, and what does it mean to me in terms of retesting certain things? The other topic of dependency analysis is kind of related to this. We don't have very good way of capturing the definition of a feature or a component right now, and because of this we cannot really build models of our existing components or feature. If you are able to do that, then a lot of interesting things can be done later on, like coming up with dependency analysis, generating dependency graphs and figuring out what is the most optimal way to traverse certain states to get maximum bang for the buck. All those things are enabled if you actually have the system described in a particular way and then write tools around it. And that's a great way to actually do impact analysis. We keep asking this question every day during the ship cycle of what is the impact of this change. Is it risk? How do you do risk management? When we actually ship product, most of the time at the end of the product cycle, we are just doing risk management of making sure that whenever we change something, we are not breaking something else. And what is the risk? Cost benefit analysis of making some of these changes. We don't have very sophisticated tools to do that right now. We heavily rely on experience of the dev and test lead and a manager, and it's just his gut feel and the experience is what he kind of relies on to make some of these calls. And in some cases they are very good judgment calls, and in some cases they are not. And in some cases we get more worried about it unnecessarily and over test the system just because we have this fear that maybe something is missing. One good example is server appliance. That's a very recent example. We are actually hurriedly trying to figure out how to repackage our Windows 2000 system and give it to OEMs as web appliance SKU, right? So you want to make sure that this special CD comes up which can go to Dell as a web server or some OEM like a web server or a file server or just a DHCP server or whatever. And right now there is no easy way to figure out if I disable certain services in the system or if I put ACLs and not allow certain services to start, all this dependency between the services and registry settings and other things which is there in the system, it's very difficult to figure out what is the minimum test hit to make sure everything is fine when you make certain changes like that. The dev cost to do these things is very simple. You just disable certain things and create a CD and there you go. But to make sure that you're testing adequately and not overdoing it is a huge challenge. The other thing I mentioned about the models, I know quite a few people are working on this problem in Bell Labs and some research community, and even in Microsoft, James Tierney and Harry and some of those folks are actually trying to apply this model-based testing approach where you kind of model the system and then automatically generate optimal test cases. And the examples I've seen so far are very trivial or very simple examples. How those things can scale to a code like NT, where in a file system or a redirector or a security subsystem is a huge challenge. I mean, if you can make that happen, that'll be awesome. The other, apart from the scaling aspect of it, the other challenge is we have close to about 30 million lines of code, and applying those concepts, if the solution is start specking out things in a particular way and developing code in a particular way, then that's good, but it's not going to help deal with our 30 million lines of existing code. And I don't think in next 1 or 2 years we're going to add 30 more million lines of new code. So we need to kind of solve the problem with existing source code base and test code base we have to deal with this. And the other problem is we get more and more quite a bit of things from third party. So whatever processes we put in place, we need to make sure they can be applied to the third-party vendors and the code and the engineering practices they have. So that's the challenge, and there's a huge cultural shift also. Right now, it's a big challenge to even force the program manager and a developer to give a decent spec, which is like a one-page Word doc. If you actually force him to go through some elaborate, couple of months of describing the system, I don't know how difficult it's going to be to roll these things out. So it needs to be very easy and not very cumbersome for people. The other area is robustness and reliability matrix. For Windows 2000, we have made good progress actually. For the first time, we were able to track the mean time to blue screen and mean time to reboot statistics for the system. It was mainly on the machine level uptime statistics, and we were actually able to measure that and correlate our numbers and kind of predict forward what the behavior would be when these things were rolled out on thousands of servers in ITG. And the numbers which ITG got, we could actually correlate to our internal measurements. So that was a good thing. Anita here, she did quite a bit of work there in that area. One thing which we need to do better is to actually track service level uptimes and reliability and robustness numbers. We have not gone down to that level as yet. That's the next thing which we need to focus on. The other thing is client-side robustness. Now we have something called workstation stress to make sure the desktop is robust, but there is this other thing about creating usage patterns on typical clients and making sure that those scenarios on the client are robust is also something which we need to focus more on. Another problem is the end-to-end scenarios. A typical example I have is this whole thing of downloading profiles and policies on the desktop. A bunch of things have to work in the system to make that happen, and that pretty much works. But when Bill G demos it for the launch, the 49th time it doesn't work. Right? It's just flakiness is there in these end-to-end scenarios, and you may call it either robustness, reliability, or anything else, but there's no way to measure that. How the end-to-end scenarios are reliable or robust. There's no matrix for that. The other big problem is to capture the real-life loads. There are some specific targeted applications where we can track hits to the server and web usage and other things. But in general, capturing the real-life load and replicating into the test environment is a very difficult thing right now. There are no intelligent tools which we can use. My favorite example there is We actually have worked a lot with Barnes and Nobles to understand their whole backend infrastructure and how their order processing works and everything, and we have successfully replicated that in our test bed to make sure we can withstand those loads. But it's very expensive right now, the number of machines involved, the custom data from these vendors and all that stuff. I mean, you cannot just do that regularly. The key challenge is to actually capture that load and really understand what it's doing to the system. And when I mean system, it's across different components. For example, lots of products are involved to make those scenarios work. It's not just NT, it's SQL and Exchange and MTS and MSMQ and transaction related components and some third-party solutions and clustering. So understanding all that load to the overall system and replicating it in the most optimal way by creating synthetic loads so that we can actually efficiently test for robustness is a huge challenge. That's the tools developed in that area can really help us.
Question?
Sure.
Sorry, I'm still back on VBLs.
Okay.
Suppose at the end of the week, half a dozen VBLs check their stuff on the main tree, and then you see that things are inconsistent. Who is to judge? Which group is to be blamed, and who decides who should change? Suppose even two groups and they contradict.
Correct.
Who should change its code?
So the way we handle that situation is we have certain baseline of certain level of stress or build verification results. Everyone who is responsible to reverse integrate into the main tree is not off the hook unless the system is meeting that level of stability. And we don't allow the second VBL to get in unless the first VBL brings the system to that steady state. Till that time, it's this VBL's problem. It worked before, they reverse integrated, it didn't work. So unless we actually get that stabilization level up, we don't open the gates for the reverse integrate for the other one.
But suppose the first group checked the code back, it works, but in fact something wrong with it, but you don't realize it until the second group comes, and then things become wrong.
There are cases, but the thing is, when the first reverse integrate happens, typically the VBL2 first takes that and integrates it into their VBL, and they test it there. So they have a current main snapshot and their stuff, and then they make sure everything is fine, and then they're supposed to bring it back. So most of the problems are handled in that scenario, but even then there are some surprises because the kind of test we do or how much time we spend to make sure everything is fine, there's some limits to it. So certain subtle things come up which we cannot catch.
So with the scenario that you just painted, if it turns out that the VBL1 is the one that actually introduced the error, they're responsible to correct it and reverse integrate it, and then the second one will take that copy and make sure everything works and then bring it back.
Correct. And in some cases, if it's a small thing they need to do, they just directly go to the main tree and unblock that process with an assumption that the next reverse integrate will come in with that change. Okay? So the next topic is exploding test matrix. That's another area where we spend huge amount of resources to make sure everything is right. One of the challenges, like the example which you are talking about, how do you make sure everything is fine? We don't have too much time to verify everything is fine when all these reverse integrates are going on. We need to have this build verification test. Right now the way we have it is it's not very scientific. Ideally you need to have the optimal way in which you can traverse maximum code paths in the system in the quickest amount of time to make sure everything is fine. But the time for us to make sure that basically everything in the system is fine right now takes 1 week. So that's why some of the things we don't catch in this frequent reverse integrates. There is no easy way to actually find that out in a complex system like NT. So the exploding matrix, especially in the hardware compatibility and applications compatibility and interop area, is just ever increasing. Just to give an example, hardware compatibility, we eventually end up testing, there are about close to 10,000 devices on the HCL. anything can go, any one of those devices which are shipped outside can expose a bug in NT because certain timing characteristics are involved which are exhibited only when that device works with certain other combination on a certain system dealing with our kernel components. So to make sure there is no flakiness there, we have to go through this huge matrix of thousands of devices across different categories. Same thing with application. We have close to 800 applications between desktop and server and some of the terminal server environments, and any one of these applications can expose a bug in the system, and there is some interesting debates when that happens, whether application has a bug or a system has a bug. At the end of it, customer doesn't care. The application has to work when he buys the system. So we get into all these problems of where the fix should be. But just to make sure everything is fine, there's a huge matrix of different types of applications. Interop integration scenarios is another example where it's just anytime you add a feature, you just create another dimension of interop matrix, and it's very expensive to actually do that very frequently during the release process. And setup and upgrade, there are literally several thousands of different unique setup variations and upgrade scenarios we track to make sure that all these shift environments from which people migrate into our operating system continue to work. So typically we take about 8 weeks. The way we resource our teams is to make sure that within about 6 to 8 weeks, most of the important applications, hardware, and all these huge scenario lists which you're talking about get covered so that we can ship decent, well-tested betas or release candidates out to the world. If there is some single thing we can do here to, guide what is the most optimal way to reduce these matrices and still get good results and not take too many risks, right? This is one single most thing we can do to actually reduce our, time it takes to release out our milestones and overall costs which we incur. Create file example, and those are all examples at different levels. Create file is a simple API. What would it take to just test that? But there are 51 unique, parameters and flags and all sorts of things in NT create file. And 2 to the power of 51, if you just try to test all these combinations on a standard hardware, it can take a long time. And we obviously don't do each and every permutation combination of all these scenarios, but you need to kind of look at the most interesting ones. And there's about 65 unique interrupt scenarios just to make sure that this API works across all the installable file systems, across all the different code IO type of devices which we support. So anything which you do here can really help us save costs and increase our quality. There are other examples here which I could not put it in a standard bucket here. Another interesting problem is when we actually change the system. This is typically, let's say you are dealing with last 1 or 2 weeks of a release cycle. Everything is pretty much stable, right? And all you're doing is just because of some reason you're just rebuilding the system. And the act of actually rebuilding the system, if there's no intended code change, it should just be the same. But our tools and other things are such that the compiler or the linker or the post-build process tools and other things, that we just tweak some bits somewhere here and there and we change the bits, right? And that introduces unnecessary overhead and risk to us, and we just keep, you have to retest the whole thing just to make sure nothing is wrong. And that's pretty much, wasted engineering effort. If you can be intelligent about how to make sure we can allow certain things without changing the exact bits in the image or a binary, that can save a lot of cost. A typical example is some of this patching technology we use for service packs. These things get confused. They think something has changed, but it's not really changed. It's just something small has changed there. Nothing to do with code, right? So our tools are not very intelligent in this area.
Most of the change for the first one has been because of the scenarios that you generate for BBT to optimize.
BBT is one example.
BBT, because the scenarios change because of the timing factor, they are not exactly the same. BBT reorganizes the binaries in a different way.
Correct. And in some cases, it's not predictable.
Yes.
When you do it 3-4 times, you should get exactly the same result, right? I had this problem where we had Windows 2000 is released now. Now you want to give it to sustain engineering, and you want to build this system on different set of boxes in some other building and get identical set of binaries, which we shipped, so that we have a clean slate to start with. It's a difficult problem. Unless I use exactly the same binaries, I cannot be sure that I am starting service pack tree with the same exact bits to the customer. So because of the tools, I think that they are not really you cannot repeat certain operations and get the same result.
We need to sacrifice some performance.
In this case of it's a simple problem. I want to start sustain engineering with exactly the same snapshot of the memory, not at the source code level, at the binary level. It should be possible. It should have identical performance. All I'm doing is just building the system in some other environment. That's all.
Yeah, the reason is that because BBT, for example, like BBT uses time order bits. And that's a function of time, so you do not get exactly the same scenario. So it does a different transformation.
Correct. And then the performance characteristic would be a little bit different. Yep. So and apart from BBT, there are other tools also which we use, which unintentionally do something which has used cost actually. The other thing is all the work which we do of scanning the source code and finding problems is a huge benefit. John is nodding his head. The prefix is a great success for us. You just run this thing and create thousands of problem reports, right, without wasting time with testing. This is huge. Developers can do it on their own if they want to, right? Simple things like PC lend. Doing more of that, right, is going to give us a lot of saved engineering work, in my opinion. And we are driving that pretty hard actually in Windows 2000 teams. We are going to schedule another prefix round when we finish code complete for Whistler, and everyone is committed to dealing with that. In addition to just doing whatever we did with prefix, there are quite a few things which we do, which we can do to actually help the developer write better code. We have a lot of knowledge base actually of if you talk with people like Neil, Clift, and Landy, and Silvio, and these folks, they can tell you quickly, these are the 10-15 problems which a typical device driver developer does. Or these are the typical, they're pretty class specific problems actually. And capturing that knowledge and putting it into the tools so that our IHVs can actually benefit from that is something which will be awesome.
What I was actually nodding about is that that's the really leverage stuff, getting the knowledge to the developers. Embedding it in the tools to check is fine, but it's just so much cheaper if they know this and don't make the mistake to begin with.
That is true. Yeah, before they make the mistake, if they can understand that these are the typical 10 mistakes someone else made and I can avoid it, right? That's huge. But right now, there's a huge laundry list of things, and if you talk with some of the experts in certain areas, people who write, what are the 15 different bad things application developers do, which we have found in our application compatibility testing, where we have spent hours, thousands of hours dealing with that mess, right, and trying to make our system compatible with those applications. Same thing with drivers. There's quite a bit of work which we can do there to keep improving there. The other interesting problem is the day on which I can actually build NT system for US and within few hours get 25 languages all built and ready to test, right? That will be a huge success. Right now, the tools and the processes and other things which we use, the deltas between creating all these other languages and building products for different languages is pretty much, in some cases it can take weeks before we get all the 25 languages built. Some of it is just processes and some of it is tools. We actually did quite a bit of improvement there for Windows 2000. We had within 24 hours a German build as soon as the US build comes out, and as soon as you do that, you can save a lot of test effort because you're testing the same build. I could actually say, okay, instead of US, just use German, You're not looking at the UI anyway. Just test those bits to make sure they're included in the test bed. People don't tend to do that if there's a lot of deviation between US build and some other language build. They don't want to be on the older build, right? So there are quite a few benefits of actually reducing that gap. Another interesting problem, me and Amita we're talking about it right now actually, is converting this huge raw data we have which comes in. One of the key challenges when we ship product like Windows 2000 is just data mining. All the data coming from lots of different sources and making sense out of it and prioritizing it so that the individual developer or a tester is totally focused on doing the exact, what is the most important thing for him, is a huge challenge. The tools which we have, we're kind of incrementally improving that, but understanding raw data which is going on in the news groups when people are talking about our products, in the PSS reports where people have reports and all the text associated with all the issues, the phone conversations which are taking place between customers and PSS, the email communication on bunch of aliases which are going on, and all this stuff. If you can just tap into that and figure out, because the time someone actually starts talking about this problem, and between that time and the time at which the developer considers it as a showstopper bug and starts fixing it, that gap is just huge. And most of the time we have quality problems is because of that. This is huge pipeline is there, and if you can reduce that time by using intelligent tools and heuristics, that would be great. The other problem is in the hardware industry, they do a very good job of this. This design for testability, this whole concept of making sure you help design systems in a way in which they are more testable. If you go to hardware chip manufacturers and all those folks, you cannot just you cannot imagine they tweaking their hardware at the last moment to keep testing things. They need to have this discipline of making sure they invest a lot in the front end process to make sure that system is testable and complete, because they know that the cost of not doing that at the end is huge. They just have to scrap all this hardware. Because we don't have that cost is not very apparent for us. We don't spend too much time planning ahead in the engineering process to figure out how do you make sure the system is designed so that it's testable in a cheap way, rather than exploding all this code, enabling unnecessary code paths and making it complex to get into the system to test it. Another problem is NT, we get hammered for actually having a lot of code in the system. It's very difficult to rip things out actually. No one knows whether anyone is using anything of this stuff. If you took a typical web server, poll thousands of web servers running certain things, and if you can find out what is actually getting used in the system, where is this dead code? There's some research done where you can find out. Even some of the compilers and prefix can tell you that certain code paths are not reachable, and that you can find out that there's no way in which you can reach this code. But that is a different problem than the problem of, okay, the code is theoretically reachable, but there is no customer using it. We're just carrying this stuff as a legacy and just paying recurring cost for that. There's no intelligent way to find that out right now. And you just carry along all this legacy code forward because we just have this fear that something is going on there. Especially for a system like NT, it's very important, and because it's kind of getting bigger and bigger, unless we figure out how to kind of obsolete certain things without breaking customers. That's an interesting problem. So those are some of the things which I wanted to talk about. There are quite a few things I mentioned here, but this is my wish list. This is some areas where we can actually get maximum bang for the buck. Apart from the obvious one of things like prefix, where there's a great benefit of everyone using it and saving a lot of test time. One is dependency analysis. If you do certain cool things there, lots of applications can be developed around it, and tools could be developed around it. I can immediately see 5-6 areas where we can apply this today to do a better job of doing testing. Containing the exploding matrix, if we can actually figure out what are the most optimal ways in which you can reduce this matrix and still not let the quality affect, that also will be a great success. And robustness matrix, like I mentioned, apart from just server uptime, if you can also look at some of the service level availability and reliability and robustness matrix and things which can actually let us have confidence that end-to-end scenarios work at a particular reliability level, that will be great. And another point I wanted to make here is my experience is whenever we actually come up with some of these cool tools or ways of actually helping some community, as long as you make those tools easy to deploy, because the end customer of all the things we do is an individual tester and an individual developer. If you can make sure that that guy can really understand the value of it and quickly use it in his day-to-day life, that's where we get maximum bang for the buck. There are quite a few tools and bunch of work done, I think even within Microsoft, where it's very difficult to deploy it with thousands of developers and testers because it has not been packaged or put in a form in which people can easily use it. That's something which is very important for widespread acceptance of this. So that's what I was going to cover, and one thing which I was going to actually show you is just to get a glimpse of what we do day to day here. I don't know how many people have seen the daily cycle of NT, just to get an idea of what we do every day there, but I thought I'd just show this if proxy settings are detected properly. So I cannot go on web from this one.
Do we know this machine's on the net? You tried it before? It wasn't last week.
Actually, it was on the web. I got my PowerPoint slides on the net here. Anyway, forget it. If I can get the net, that's fine. On WinWeb there is a daily life in NT group, in a daily cycle of what we do here. There's a video which I can send the link to you and you can see it there. So if you have any questions, you can talk about that. Any points you want to make which can help. The purpose for this is to just create some communication channels and just to make you aware of some of the problems which we have, which you can immediately use solutions if someone has them, or something going on in the research community or your groups. There are people. There are a few people from my group: Chris Walker, Silvio, Rajesh, Anita. They actually deal with some of these problems in our group, and they will be very interested in talking and working with some of you here. If you have some ideas. You had some question? Someone had a question here.
I was curious how much reducing the test matrix is a design goal. So a lot of this has to do with the architecture. Some of it does anyway. Are the architects really thinking how are we going to
make that happen in the early design stage?
Priority on everyone's list? Small test matrix? Nice.
Actually, I wish that was the case, but unfortunately right now no one is giving serious thought to it, in my opinion.
Okay.
Whenever we come up with a design, no one is really thinking about how can I do it in such a way that I can reduce the paths which are unnecessary, right? There are some isolated cases where they do that thinking a lot harder and then there are benefits, but there's no organized way of doing that. I don't know whether there could be tools which could help developer or the guy who is designing it to kind of guide him in this area to kind of reduce the matrix, but not enough has been done, in my opinion.
Even something to show you. You just created an interface that's untestable. Some quick analysis that people can comprehend that they just did something they may not have noticed that.
Yeah, I mean, if you can, the challenge is this distributed build environment. We are allowing developers to pump in code as fast as they can, and my fear is we are not throttling at that level enough. If there, and I don't know how to do that other than just giving messages to people, unless there are some tools to actually enforce some of this. but you're making a valid point. I mean, that's where it needs to happen. Any other questions?
Point out when you talk about static analysis tools, one area where we have very fancy tool is deadlock analysis. We're pretty active about corruption, fraud, injection. For deadlock analysis, you just wait for disaster to happen. Just have all sorts of stress and it happens really buggy, but
very expensive way of finding that in test. So we can do something there to look at the code and find out. It's a good way. Okay. Thanks a lot.